Hey, hi Rasmi. Uh,
Hi, Ankur.
hey, welcome to the mock interview, data engineering mock interview. So let's start. Will you like to give brief intro about yourself, your journey, your career, information about your careers and your college?
Yeah. So, hi, Ankur, first of all. So, I'm Rashmi Roila and I'm working as a data engineer too in Ashton by Deloitte. And my journey in data engineering started in November 2020 from Infosys. So, I have around 2.5 years of experience. And meanwhile, in my career, I have worked on different use cases involving big data technologies like Spark, Kafka, Hadoop, Hive, HBase, and GCP, BigQuery. So these are the technologies on which I have worked upon, and the use cases where they involve reading data from Kafka and writing data to DBs, NoSQL databases, for example, HBase, and in some cases writing data on Kafka topic only. And I have worked on batch pipelines also. So where we are reading data from files and writing data in BigQuery or in some database. And apart from that, I have also worked on API development. So yeah,
Cool.
thank you.
So let's start with your one of the use case where you mentioned about streaming part. Okay, let's start from that. Will you please explain your project in a little depth, which from where you were reading it, how you were processing it, how you were syncing data to something. Just explain that particular project in a little depth.
Okay, so this was one of our client that was FPL, Florida Power and Light. So for that I was working, and in that project we were reading data from, first of all, the data which is coming over there, it is coming through sensors. So there are multiple types of sensors which are installed on electricity meters and on equipment on and on current lines. So multiple sensors used to be there in
Mm-hmm.
power sector.
Mm-hmm.
So those sensors were sending some data to our pipelines. So in some cases, the data is directly coming to us through Kafka. And
Mm-hmm.
in some another cases where data was coming through some, by processing by some other jobs, like data was processed before coming to us. So
Mm-hmm.
that was also coming through Kafka, and in some cases it was coming as a Hive data as well. So some internal tables were there in Hive, and from there we were reading the data. So
Okay.
firstly, streaming.
Mm-hmm.
So from Kafka, data is coming on. There are multiple topics, and through those topics, data is coming to us, and we have written Spark jobs which are connecting to that particular Kafka topic and reading the data and storing the data in HBase. And now the data which is stored in HBase, we have some APIs which are taking the data and displaying the data on UI, and that UI is helping technicians to know where is the fault at which particular pipeline is not having current, or in what area the issue is. So that kind of decisions our data is helping to make. Yeah.
Cool. Okay, let's start from very beginning itself. You mentioned about you have multiple Kafka topics, and one of
Yes.
your source is Kafka, right? And another source is some Hive tables. It
Mhm.
means that you are reading from two sources. One is Kafka, another one is Hive. So help me to understand the when you are reading from Hive table, was we were reading that from that Hive table in your streaming job itself, or there was some batch pipeline. How was that planned?
There are separate jobs, so it's not like a same job reading data from Kafka and as well as reading data from Hive, but
Mm-hmm.
we have two separate jobs. So the
Mm-hmm.
data which we are reading from Hive tables, those are the batch jobs.
Mm-hmm.
So those jobs will connect to the Hive tables and read the data, and again transform the data and store the data in database. And Kafka streaming jobs are different, so they are
Okay.
connecting to Kafka and
Okay.
storing the
Means
data.
yeah, you are having two pipeline. One is
Correct.
batch, one is streaming. In batch, you are reading from Hive, and your streaming, you are reading from Kafka. Now
Mhm.
your sync is HBase. Okay.
Huh.
So yeah, so you were syncing to HBase directly, or you were syncing into some files, and then you will creating HBase on top of that. How was that?
No, we are directly dumping data, or we are directly saving the data in HBase tables. We are not dumping the data in Parquet files. But there are some scenarios on which we are still working on the development. So in that scenario, we are storing the data in Parquet files, because for now the further work is in progress, where we are trying to store the data in HBase, but due to uh, due to some lack of work, maybe we can say. So in that scenario, we are storing the data in Parquet files, not in HBase. And the work is in progress. We are working on storing the data in HBase.
Okay. So in both the scenario, help me to understand. So you're seeing that HBase was different for your batch pipeline, the HBase tables were different, and your streaming pipeline, the HBase tables were different. Am I right?
Yes, but there are some scenarios where the tables are, table is same.
So how you were
So yeah.
merging the data? Let's suppose uh, when your batch pipeline ran and you dumped some data. After that, your streaming pipeline ran. It's trying to dump. How you were merging that HBase table?
We are always considering that the data which is coming from Kafka, it is the correct data.
Okay.
So, for example, our batch pipeline, batch job ran at 2 o'clock, and
Mm-hmm.
it read some data. So it is
Mm-hmm.
storing the data in HBase. And
Mm-hmm.
now at, for example, 3 o'clock, same record came from Kafka. Now in HBase, there is a overwrite mechanism, and we can store versions of data in HBase.
Okay.
So currently the version is 5. So we can store 5 version of data, or 5 history data in our database. And
Mm-hmm.
in HBase, we have a column family and column qualifier. So for example, in a column family C1, there is
Mm-hmm.
a qualifier Q1, Q2, Q3.
Mm-hmm.
And from HBase, we receive data from column family C1 and column qualifier 1. So
Mm-hmm.
only Q1 we have received the data.
Mm-hmm.
And no, let's consider that for Q1 and Q2, we receive the data for 2 columns.
Mm-hmm.
Now, from Kafka, we are receiving data for 4 qualifiers for the same
Mm-hmm.
column family: Q1,
Mm-hmm.
Q2, Q3, Q4.
Mm-hmm.
And but we have not received data for Q1, and we have received data for Q2.
Mm-hmm.
Now, how HBase will work? It is an internal process of HBase, how it works. So it when we will try to store the data with the same row key in our database, now
Mm-hmm.
Q1 will remain same, but
Mm-hmm.
Q2, as we are receiving this data again for the same qualifier and for the same row key, it will override the data, and the previous data will be stored in backend,
Mm-hmm.
because we are maintaining 5 versions of data, and Q3 and Q4 will be stored from Kafka as it is, like whatever it is coming.
Cool.
So yeah.
Okay, cool. Let's move back little. Let's go to Kafka now. You told that you were using multiple Kafka topic. So the first thing that you help me to understand, what is Kafka topic?
Okay, so imagine that we have multiple pipes, like,
Mm-hmm.
and those pipes. I mean, consider that we have a big square kind of thing, or it's a cylinder, and from
Mm-hmm.
that cylinder, multiple pipes are going through. So
Mm-hmm.
here, that whole cylinder is Kafka, and the
Mm-hmm.
multiple pipes which are coming through, which are there in between. So those are the Kafka topics, and from those pipes, the data is flowing. So a particular type of data can flow a particular kind of pipe. Now the pipe
Mm-hmm.
name is topic here.
Okay.
So yeah.
Okay. Help me to understand one more thing. You said there are multiple pipes, but Kafka is a distributed messaging queue, right? So if let's suppose I am considering cylinder as a cluster and if there are 5 pipes, it means 5 topics. How my data is actually distributed? If there is only one pipe for one topic, how my data will be distributed then?
Okay, so inside the topic, we have, first thing is, Kafka is a master slave architecture. So
Mm-hmm.
we have a master and we have multiple slaves, and those slaves are brokers. So on
Mm-hmm.
those brokers, our topics are partitioned.
Mm-hmm.
So, for example, we have topic one, and in the topic one, we have 4 partitions,
Mm-hmm.
and and in topic one, we have 4 partitions. That means, and we have 4 brokers. Now, on broker one, partition one will be stored on broker two, partition two will be stored, and 3 and 4. So in this way, it is a distributed way, and Kafka is also fault tolerant. So we are having the replication factor as well in Kafka,
Mm-hmm.
so
Mm-hmm.
that if any broker is lost, so
Mm-hmm.
we can retrieve the data from another broker.
Cool,
So
got it. Okay, let's try to understand one more thing. You mentioned about you are using multiple Kafka topics. Okay, is those data from different topics correlated? When you sync it, how does you sync it? Will you do any type of joins or something, or you, for one topic you will just sync it into HBase table? For one topic you will just sync it into HBase tables. Are those the events which are coming from multiple topics are related?
no, they are stateless
Okay,
way, like
they are
uh,
independent of each other. Cool.
correct.
Okay, help me to understand in single topic itself. Let's suppose how do you handle late coming data? I hope you understand what does late coming data actually means.
Late coming, that means so basically
Let,
here
let me
uh,
try to make you understand what does late topic actually means. Let's suppose from your sensors you get one reading, okay, A, and time stamp is just one, okay, which is your current things. Let's suppose one new data was generated, B, or let's suppose your primary key remains same, 1A and timestamp is 1. New data is generated, 1B and timestamp is 2. Okay. But what happened when you are dumping data from your producers to your Kafka? It might happen that due to network or there can be multiple other scenarios. Your your old data might come to you first, and then your latest data comes. As a consumer, this can be happening, right? This can happen, right? How do you handle it? Or let's suppose you are getting my questions, right? If you are not getting my
yeah,
question, okay. So how do you
I
handle it?
understand. So, for example, firstly, we received a data of timestamp 2, and after
Mhm.
that, a data that has timestamp 1 that is
Right.
coming.
Right.
So, basically, before pushing the data on HBase, we
Mm-hmm.
are comparing the timestamp. For example, if the data already exists in our database, so firstly, we are going to our database and extracting the data which is already existing with the similar row key. So
Okay.
if that data already exists, and then we will compare the timestamp which the timestamp of the data which is there and the timestamp which is coming. So we will compare that, and if the timestamp of the data coming data is greater than the timestamp of existing data, then we will overwrite, else we won't overwrite.
Okay, means you have another layer of cost. Means before syncing it to your sync system, that is HBase, you are actually reading whole HBase data, right? You are actually reading whole HBase data. Then you are comparing your timestamps, and then you are dumping this data. In this way, you are managing your late coming data. Correct me if I'm wrong, right?
Mm, Actually, in Kafka, I don't think that this scenario is possible because I have never faced this
It
problem.
can happen. It can happen if the producers
Okay.
are actually not partitioning, and they are not partitioning on timestamps and partitioning on that particular primary ID. So it can happen that you might receive some data little late, and
Mm-hmm.
some data but you are doing good. But one layer of cost you are adding, because
Yeah.
it will not create problem to your systems, because you are always checking your sync system, you are always checking your HBase table, and then you are dumping it. Okay, and that also help you to solve the idempotent problems, like whenever, let's suppose by mistakes you ran your pipeline, then
Mm-hmm.
also the duplicate data will not be happening in HBase. But there are other way to solve this problem too. There is concept of watermark. Do you know?
Watermarking, I once read on, but for now, I'm not able to remember that.
Cool, cool. Okay.
Can you explain me? Maybe if you will explain me, as I have already studied, so I'll get
Yeah.
it.
So before going to that explanation, help me to understand. You are using Spark streaming or Spark structure streaming?
So basically, in most of our jobs, we are using Spark Streaming, but
Mm-hmm.
in very few jobs, like we just now wrote, so in those jobs, we are using structure streaming.
Okay.
But
And so you using checkpointing?
yeah, in structure streaming, we are using checkpointing.
So what is checkpointing?
So basically, checkpointing is used to store the process data. For example, before writing data to Kafka, we are doing a checkpointing mechanism where we will be storing that this is the data which is processed. And for example, we are processing data from 0 to 1 to 10, and we have processed it safely. So we will be doing a checkpointing that, before storing the data to HBase, that this data is processed. Now
Mm-hmm.
uh, and that checkpointing directory, that would be some HDFS location, and
Mm-hmm.
where we are storing the data. And for example, next we try to process from 11th to 20th data, and in between our job failed. So as our job failed, we will be knowing that, okay, this is the point from where we have to restart the processing. And in
Mm-hmm.
checkpointing, we are storing the data as well as the offsets also, that up to
Mm-hmm.
this offsets we have processed, and those kind of things. Yeah, so
Cool.
that
Okay.
helps in a failure.
Yeah. So there are typically two things that is stored in our checkpointing. One is called offset stores that you just mentioned, that
Hmm.
you are maintaining from which offset to which offset you have actually consumed, which offset to which offset is actually remaining, right? So it helps you. It helps you whenever there is some failure. It helps you to what you decouple the producers. What does this means? That whenever the data is coming, you are not reconsuming it, right? Because you are already writing it in checkpointing. Like
Hmm.
124 in partition 124 offset I have already consumed. So next time I have to consume from 125. That's the one thing. The second thing that you can maintain is the maintaining stores in your checkpointing directory. So
Hmm.
what first thing is just offset, second thing is a store. What does stores actually means? You can actually, let's suppose you are applying some group by or some aggregations operations. What you can do, you can always store your that particular information, that store information after doing the any aggregations or group by in your checkpointing directory. And how does
Correct.
it help you to implement watermark? You can define that I am having watermark of 5 minutes or 30 minutes. Okay, it depends
Okay.
upon you. When you define your watermark of 5 minutes, what it will do, whenever the existing data is coming or whenever the new data is coming, it will always check the old data, and it will automatically compare that,
Ah.
oh, this is the time per stamp, so I have to
Mhm.
update my store informations. This is actually wrong, this is not right. So in this way, a watermark helps. Okay, cool.
It can only store 5 minutes. We have to specify the time interval, is it? So
Right.
if our data came maybe 1 hour back or 2 hour back, so in that scenario.
Yeah, in that scenario, your checkpointing directory will be very huge, and that can create problem.
Hmm.
And that is my next questions to you. So when you are saying that you are storing checkpointing directory on some SDFS, what is the reason of storing into SDFS? Can't we store in simple file system? Why you have stored in SDFS?
uh, uh, a checkpointing, uh, uh, as it is a distributed system, so uh, maybe that's why we have to store it on, because checkpointing can be a big file. And
Mm-hmm.
so in that scenario, we may require a distributed storage, so that our other storage won't fill in.
Cool. Help me to understand. So will the replications or the copy of checkpointing will also be available on each executor, or executor will only whenever they need it, they will go to that particular file system and they will read it, or the copy of checkpointing information is always present on each and every executor? How is the scenario?
Okay. So copy of checkpointing, uh, I don't think it is visible. Actually, basically, I have not worked on checkpointing much. So
Mm-hmm.
this is what I am thinking how it should be.
Mm-hmm.
So checkpointing basically is used when some okay, but if we are doing watermarking, then it should be present on each executor.
Yeah,
Yeah.
actually it is present on each executor
Uh,
because it's for fast lookup. Otherwise, if
hmm.
executor has to go again and again, yeah, right, that can create problem. Okay.
Yeah.
Do you know about consumer lag, and if you know, how do you maintain in your pipeline? What is consumer lag?
So consumer lag is that is the threshold, that up to this threshold, our messages can be segregated. Can be present on our Kafka topic. But if it
Mm-hmm.
increase from that threshold, then there is some issue with our consumer, as it is not consuming with that speed that it should process the data. So
Mm-hmm.
in that scenario, that lag will be there. So how we were handling that, it was we were having a particular job in our system, so which was continuously going to different topics, checking all the topics, that what is the lag at this particular topic. So
So
if that
sorry to disturb. So there was another jobs which was doing it.
yeah, yes,
It's not in the same process. Okay, cool.
it's not in the same process. So we are having another job which is running in a batch kind of system, or in every 10 minutes. I think it's yeah. I worked on that one in Infosys, so that's why.
Cool, not a problem.
Maybe it was 1 hour or
Mhm.
half an hour, something like that. Some interval was there, and it was running, and it was checking all the Kafka topics, like what is the lag on that particular topic, and we have specified the threshold in our config file. Then, if that threshold increases, I mean, if the lag increases more, I mean, if the lag is more than the threshold, then our job will trigger emails, and everyone will receive emails. And if that thing happens, then we used to increase the number of consumers. So generally we have around 4 to 5 partitions in our topic. So we increases the number of consumers in that particular consumer group.
How do you increase? Do you stop your jobs then increase the consumer?
Yeah, we stop our job and increase the number of consumers. I mean, we have specified that value in our config file. We increases the number of consumers, and now it started processing faster, because each consumer will be connecting to that particular with the partition and processing the data.
Cool.
So, yeah.
Okay. So that in this way, but you had mentioned about a Spark streaming, right? So if you are using a Spark streaming, you can always write back your offset back to Kafka topic, right? Will this also do?
Yeah.
Yeah.
Yes. So the offset which we are committing, it is basically stored on the broker. So for example, for partition 1, we have processed up to 10th message, then it will commit 11th offset on that for that particular partition. And as there are two consumers which are running under a group, and consumer 1 is processing from partition 1, then it will commit his own offsets on the broker.
Good. So were you implementing any aggregations in your streaming pipeline?
Aggregations, basically in batch jobs, we are doing aggregations. And in batch jobs, what we are doing is we have already stored data on Hive tables. We are reading the data and aggregating on, to identify the cost for a particular equipment or particular type of equipments, as multiple equipments will be bought by our bought by the teams. So we have to identify the overall cost for that particular which we have spent on that particular equipment. So in that scenario, we are using aggregations. Yeah.
Cool. Okay. Help me to understand where your Kafka was actually deployed.
It is deployed on on-prem cluster. Yeah. Everything is on-prem.
Everything is on-prem. And let's suppose if something happens to your Kafka cluster, how we were notifying, how it was notified to you, because your application will stop, right?
Yeah. So basically, for that we have a admin team, and if there is some issue, they used to notify us, and they explain. They notify us that there is some issue. Basically, meanwhile, I have worked there on around 1.5 years, so I have never faced such issue till now.
Okay, let's create one scenario. Let's suppose your admin teams just convey you that Kafka clusters might not be working. Okay, might not be working and for 3 hours or something like that. Okay, so whenever the Kafka clusters will start, it will just keep pushing large volumes of data to you, right?
It stops. Can you repeat? Sorry.
So let's suppose if you're by some mistakes or by some bug or something, your Kafka clusters is not working, right? Or you're not able to consume it. Let's suppose your pipeline failed or Kafka clusters fail itself, right? So it can, whenever your pipeline will restart, it will have large volumes of events coming to you, right? Right? So how do you handle that large volume? Have you applied any back pressures there, or your application was able to handle all those large volumes of data?
Yeah, actually, we have used back pressure. I mean, we have specified the minimum number of messages which can be
Mm-hmm.
read by our consumer. Minimum partition messages which can be read by our consumer. So,
Mm-hmm.
in that way, we are handling that.
Yeah, will you please explain back pressure in very layman term? What does back pressure actually mean?
Okay, so basically, Kafka is the one which can buffer the data.
Mm-hmm.
So we will be specifying that for these many days you have to store the data in your memory. So for this is our consumer and this is the data which is coming inside. And
Mm-hmm.
if this particular data speed is very much, then on the other hand, our speed of dumping the data is somewhat slow, then it will create a problem. So
Mm-hmm.
in that scenario, what we are doing is we are applying a back pressure that okay, only these many number of messages we can process, and these many, the number of messages which you are pushing, these many I can't process. So that's why this is we are applying a back pressure on that. That
Mm-hmm.
only these many messages I want and I can process.
Okay, cool.
So, yeah.
Got it. Okay, I think we are out of times, but just a last question. You mentioned about you were having number of partitions 4 in your Kafka topic, if I'm not wrong, right? How you have decided that number of partitions should be 4? Is it related to your Spark applications or some random case, or how you have actually come to that conclusion?
Okay, so basically in our job, mostly we are receiving four types of data.
Mm-hmm.
Basically, we have decided it on the basis of type of data which we will be receiving,
Mm-hmm.
and so according to that we have decided. So in our scenario, it was like we will be in some scenarios we will be receiving data from directly from customers. Like
Mm-hmm.
some customers may be raising complaints by their own by
Mm-hmm.
using website, and the other way is by calling them. So in that scenario, the flow of data would be different, and in
Mm-hmm.
some scenarios it can be from the particular meters, like from electric meters they can also raise by their own, like some mechanism is there, we used to
Mm-hmm.
get data from there. And there was one more source, so on the
Mm-hmm.
basis of those source from where we can get the data, on the basis of that we have divided the partitions.
Okay, cool. I think Rasmi, you've done good. This is the end of the interview. Thank you for taking your times and agreeing for giving the mock interview. It was fantastic. Good luck for your future. Thank you.
Thank you very much,
Yeah, thank you.
Ankush.